ग्रुप में ऐड करके वो जो मतलब नहीं ज्वाइन कर पा रहे।
हाँ, तो उनको आईडी से हेल्प नहीं होता है क्या?
सर होता है ना उधर मीटिंग में, स्टार्ट मीटिंग में वो यहाँ पे सर लिखा होता है ना ऑप्शन ज्वाइन मीटिंग, वहीं पे आईडी देनी होती है और ये खुद हो जाता है ज्वाइन।
जरा उनको थोड़ा सा हेल्प करो, जो भी आपके दोस्त है, प्लीज डू हेल्प देम। आई विल रेफर टू यू। उनको मैं आपका फोन नंबर दे करके आप उनको हेल्प कीजिए, राइट?
ओके सर।
हाँ। बोर्ड नजर आया क्या?
यस सर।
You do you look at this ID
यस
616? Please share this ID with your all your friends so that whosoever is interested, let him join the lecture.
ओके सर।
Today's lecture is on today's lecture is on problems on projectile motion. Projectile motion, and problems are from the source NCERT, right?
यस सर।
So let me start. I will refer you to the problem number also. I will refer you to the problem number also. Problem number chapter 4 from NCERT book, and problem number 21. You can have a look on those problems from NCERT. It is problem 4, chapter 4, and problem number 21. And the problem is like this, have a look. A particle is projected with an initial velocity v0 is equal to 10j. I mean, the object is projected in the y direction initially. It's an initial velocity. It moves in the xy plane. The particle moves in the xy plane. It moves in xy plane. With acceleration a, that's equal to 8I plus 2j. This problem does not pertain directly to projectile motion, because in projectile motion we have acceleration due to gravity vertically downwards with 10, value of g as 10. But here acceleration is something different. It's a planar motion, of course, but not directly a problem on the projectile motion. In projectile motion, we must have the object falling under gravity. But this problem is on a planar motion. I mean, the particle moves in a plane. So what are the questions that he asks us here regarding this problem? Number one, what he wants us to do, at what time the x coordinate of the particle, the x coordinate of the particle is 16 meters. Particle 16 meters on the axis किस time जाएगा? मतलब at what time it will be 6 meters, it is x coordinate will be 6 meters. The particle may have even y coordinate at that time. but we have to find the time at which it is x coordinate 6 meters. B, okay, he asked this same question. What is the y coordinate at that time? C part. What is the speed of the particle at that time? What is the speed of the particle at that time? It's a planar motion in which only x and y coordinates are needed. It's an xy planar motion. So your initial velocity is given, acceleration is given, and you are asked these three questions. Let me solve this question for you in a stepwise manner. It is something like this. It is x, it is y, and particle is thrown upwards initially with initial velocity. How much is the initial velocity? It's 10 in this direction. And there's acceleration also. That acceleration is 8I plus 2j. Acceleration is constant and is given by these. So first question is, at what time it is x coordinate of the x coordinate of the particle is 6 meters? Can you write displacement in the x direction? X displacement. The particle was initially at 0. At time t is equal to 0, the initial position was 0. So what is x equal to? Can anybody tell me that? V0 xt plus 1 by 2 axt square. Is that right?
Yes, sir.
Here, this is the formula. But if you would say that the particle position was, suppose x is equal to 2 at t is equal to 0, t is equal to 0, suppose, then your x would have been this plus this 2. Yeah, if you would say x is equal to minus 2 at t is equal to 0, then initially you had to add minus 2. That means x is equal to this minus 2 plus this and plus this. But he says the particle starts from origin, so you don't need to add something initially like plus x0. Basically the relation is x is equal to x0 plus v0 xt plus 1 by 2 axt square. But you generally write this because in most of the cases we suppose this x0 is equal to 0. That means the particle starts from the origin. Is that right?
Yes, sir.
And so you must be very careful in other complicated cases that sometimes you may have to add x0 when the particle does not start from the origin. It starts from somewhere else. There you have to add it. It may be even positive, it may be even negative sometimes, right? Okay, but now we are here, it is very simple. Now here x is equal to 16 as he is given. What is the initial velocity in the x direction?
0.
That is good, that's good. It is 0 because initially the particle moves in the y direction. It has total y velocity, not any x velocity. So 1 by 2, what is the x?
8I.
8I, don't write I, 8 t square. That gives t square is equal to, that is 4. That 4, 16 divided by 4 is 4, and t is equal to 2. You got the time. That solves this A part of the problem. Now what about the B part? What is the y coordinate at that time? What is the y coordinate at that time? B part. Now just write down the equation for y coordinate, that is y is equal to v0 yt plus 1 by 2 ayt square. Now what should you write for v0y?
10.
10 into 2 time plus 1 by 2. What is ay?
2.
2. What is t square?
2 square.
4. Now, do you understand how to use equations in respect to directions, in x direction, y direction?
Yes.
Maybe if there's a z motion, also z direction, but here we only deal with the planar motions where only 2 directions are involved. This gets off, and it is 20 plus 4, it is 24. Is that right?
Yes, sir.
Now the C point. C is, what is the speed? Now let us find first of all Vx, velocity after 2 seconds, that is V0x plus AXT. Now V0x is 0, AX is 8 possibly into 2, that is 16. Now what is Vy? That is V0y plus AYT. What is V0y? That is 10 plus AY is, what was AY?
2.
That was 2 into 2, that's 10 plus 4, that's 14. So this is AY. Can you tell me what is speed now?
Under root of Vx square plus Vy
Vx square plus Vy square. That is root of 16 square plus 14 square. That you can find. What is angle? The velocity makes with the x-axis.
Tan
Inverse
inverse Vx.
Vy by?
Vx.
With whom it forms the theta is the denominator here. That I have told you, right? Tan inverse.
Yes.
That is Vy is what?
14
by 16.
60.
That's tan inverse 7 by 8. Copy this problem. It's a good problem. Please copy it and try to understand it in its right way. Now, there is one more question. Question number 25 of this same book, chapter 4, NCERT. Question number 20, sorry. Question number 25. Chapter 4, NCERT. The question says, an aircraft is moving at a particular speed. It is moving at a particular speed that we don't know, and it moves and moves for 10 seconds. And on the ground, there's a person here. He looks at the aircraft just above it flying. After 10 seconds, the aircraft subtends an angle of 30 degrees with the person on the ground. The aircraft is moving overhead above the person, and after 10 seconds, the aircraft subtends an angle of 30 degrees at a person on the ground. Wait, yes. And the aircraft is flying at a height of 3,400 meters. That is given. The aircraft is moving at a height of this. I will repeat the question. The aircraft is moving at an altitude of 3,400 meters horizontally, and when it flies over a person, after 10 seconds, it subtends an angle of 30 degrees on the ground about the person. We have to see what should be its velocity. Find the velocity. You can also look up the question in the book. Now, how to solve this question? Now, see, I will solve this question like this. The angle subtended by the aircraft at the ground is 30 degrees. And the aircraft moves for 10 seconds, and within those 10 seconds, it subtends an angle of 30 degrees. Now, see here, what is this distance? This is 10v, because 10 is the time and v is the speed, and 10v is the distance. So if I consider this triangle here, from this triangle, I can write tan 30 is equal to perpendicular by base, that is 10v by 3400. That will make it, this cancels here, v equal to 340 tan of 30, and v equal to 304 1 by root 3. That is v equal to, if you simplify it, it will be possibly 182 meters per second. That is the answer. Please Solve this question. Try to copy this question and do it again at your own places. Have you copied this?
Yes, sir.
Okay, good, very nice. Okay, let me go to now another question. Try to understand questions in a very nice way. And you can ask a question if you don't understand. Same chapter, same NCRT book 29. Because these are the questions which relate to projectile motion. There are other questions also which I avoid because they are not the questions which pertain to projectile motion. They may be from vectors which you have already done. The question is, a projectile is fired with a velocity v0 at an angle of 30 degrees and it goes to a range of 3 kilometers. The speed of the projectile is v0. It is given. There is a projectile having a speed of initial speed v0. It is thrown at an angle of 30 degrees and it goes over a range of 3 kilometers. Now, the question is, can this projectile with same speed, with same initial speed, can reach the distance, can reach the range of 5 kilometers? That is a question. Matlab ke, if I adjust the angle 45 degrees so that it can go to the maximum range, can with this velocity it can go to 5 kilometer range? First of all, I have to find this velocity. Then I will say, I will find, can this projectile with this speed which I am going to find can have a maximum range of 5 kilometers. If it has a maximum range of more than 5 kilometers, then it can reach 5 kilometers. If the maximum range cannot be 5 kilometers, then it can never go to the 5 kilometer range. So first of all, write the equation for this. Range is equal to v0 square sine of 2 theta by g. That is, range is 3 kilometers is equal to v0 square sine 2 theta, that is sine 60, because 2 theta 2 into 30 60 by g. What is v0 square? v0 square is 3 into g. You know this has a different unit, but keep it like that because I will not change any unit for the time being. Sine 60, that is root 3 by 2. It will be 3 into g by 2g by root 3. Keep it like that. Keep it like that. So I am finding the v0 square right now. What is the maximum range for this projectile? Having the same speed, or max is equal to v0 square by g, because in that case sine 2 theta is 1. I mean, what is the range for 45 degrees? Sine 2 theta by g. What is our maximum range?
V square by g.
V square by g, because for maximum range this sine 2 theta is 1. Isn't that?
Yes, sir.
It is 1. So what is v0 square here?
3 into 2g by root 3.
Into 2g by root 3 divided by g. Because v0 square I have already found from the previous given condition. So g gets cancelled. Where's the R max? That's 6 by root 3. It is not 5 kilometers. It is less than 5 kilometers. If you can check it out, it must be less than 5 kilometers. So even but the maximum range cannot go for 5 kilometers. So this can never go to the range of 5 kilometers. That's the answer. So when I adjust the angle at 45, I found the range, maximum range like this. So how can it exceed 5 kilometers, or how can it go even to the 5 kilometer range? The question is, it cannot go to the 5 kilometer range. That is the answer. You can find it out. You can check it out. 6 by root 2 is less than 5 kilometers. Is that right?
Yes, sir.
Now let me go to the question. Question 30. Question number 30. Question 30. Question number 30 is, an aircraft is moving overhead. Aircraft is moving, and when it crosses this overhead, a person here, it moves with a velocity of 720 kilometers per hour, a very, very high velocity. It moves horizontally, right? When it crosses this line, and below this line at the origin, there's a person with the anti-aircraft gun. The anti-aircraft gun is something like this, if I can make it properly. This is the anti-aircraft gun. It shoots the missile. When it shoots the missile, what should be this angle so that this missile will be a projectile, because it is under gravity, it will hit it. The aircraft should reach here and it should be able to hit. If it shoots vertically upwards, it can't be shot down because it moves. So it has to shoot it in a particular direction so that both meet at this point and the aircraft is hit. So question is, what should be this angle so that aircraft is hit? Try to understand the question first. And it is also moving overhead of 1.5 kilometers. Try to understand the question. The question is, the aircraft is moving overhead and is moving very, very fast, 720 kilometers per hour. It is moving at a height of 1.5 kilometers. And there is anti-aircraft gun on the ground. When it passes this vertical line, in which direction the bullet or the missile should be shot so that the aircraft is hit? So that the aircraft is hit. Do you understand that?
Yes, sir.
I have to follow this question. I have to find this theta. I am repeating the question once again. The aircraft is moving overhead with a high velocity. The aircraft gun is on the ground at the origin. Vertically, it is just on the vertical line passing. And then, in what direction the missile should be shot so that the aircraft is brought down? That is the question. So, I will try to solve this question. So the missile velocity, that is 600 meters per second. That is the velocity. Is that right? Can you tell me what is the missile velocity in the horizontal direction? 600?
690 minus theta.
नहीं यार, ये थीटा ये है ना, तो ये cos component हुआ इस सूरत में, तो ये sin था. It is sin theta. And what is this component?
600 cos of theta.
600 cos of theta. Don't feel that it must be always sine and this cos. It depends upon which way the theta is defined. If theta is defined like this, it is cos component, it is sine component. If theta is defined like with a vertical, then this component becomes cos, this becomes sine. You understand that?
Yes, sir.
Can anybody of you tell me what is the condition that the bullet may hit it or the missile may hit it? The condition is that the aircraft moving in this direction and the bullet moving in this direction, the bullet and the aircraft should move the same distance, horizontal distance, in the same time. Because after all, when the bullet hits the aircraft, the bullet moves horizontal distance this much. And aircraft also moves the same horizontal distance. So both should move the same horizontal distance in the same time. That will make a good hit. So if you allow me to write the equation, I will write this is x from here to here, and this is also the same x. So x is equal to 600 sine theta t time is equal to 720, that is velocity, into time, into 5 by 18 into time. This is velocity into time. That is the distance covered in this time. This is the velocity. This is the distance covered in the same time. So this distance should be equal to this distance. That's all. T gets cancelled. And what about sine theta? That is 720 5 by 18 divided by 600. This goes, it is 4. It is sine theta is equal to 20 by 60. This goes is 1 by 3. 1 by 3. Sine theta is equal to 1 by 3. And he says theta should be 19.5 degrees. That is the answer. So simple answer and so simple approach. The distance covered by the aircraft in the horizontal direction should be the same as the distance covered by the bullet in the horizontal direction in the same time. Equating the two, we get the answer. Okay. Now, there's another question. At what height the aircraft should fly? At what height the aircraft should fly so that it is safe from the bullet?
More
So that
than
it
the
is safe from
maximum.
the missile.
More than maximum height.
That is correct. That is correct. So it must fly like this. You see, have a look. The bullet is fired like this. The bullet goes like this, right, in the projectile way, and the aircraft should move like this. It should just above the maximum vertical height. But your theta is this, that is 19.5 degrees. The projectile motion, in the projectile motion, the theta that we consider was this. So what is h? That is v0 square sine square theta by 2g. It is v0 square, that is 600 whole square. It is sine square theta, but it is not sine square this theta.
90 minus
Because you
19.5.
see, when you define vertical height, you define vertical height. You define in that case this angle the angle the projectile makes with the horizontal. Is that right? So
Yes.
sine square theta is sine of 90 minus what you call as 19.5 whole square, because you have to consider this theta. I should have written alpha for here. Okay, anyway, that is 2 into 10. Calculate this value. That will be the answer. And the answer seems to be like 16 kilometers. It should move above 16 kilometers so that it cannot be hit by the bullet or by the missile. After all, missile velocity is very, very high. 600 meters per second is more than half a kilometer per second velocity of the missile. So that's why it has to move very, very high into sky so that it is not hit. You understand that?
Yes, sir.
Okay. Now let me go to one more question. The question is, शायद आपने किया होगा ये क्वेश्चन पहले भी मैंने आपको दिखाया है, लेकिन अब यहाँ पर आया है, मैंने सोचा कर ही दूं ताकि it will remain consistent, so that it remains consistent with what we are doing. The question is 32, last question of this chapter 4, and it is NCERT. I just write here so that you also feel you also feel that this is the question there, and you can read it from there also. The question is, a projectile is launched like this, x versus y graph, and it is launched with a initial velocity v0, and I have to find velocity at after any time. It is x component, it is y component, It is x component, y component, and the angle it makes with the x-axis, I mean this horizontal direction. In terms of v0x, v0y, in these terms I had to find it. So what is the initial velocity in the x direction? v0x.
v0x.
What is the initial velocity in the y direction?
v0y.
He does not define this theta to say it is v0 cos theta, it is v0 sin theta. It does not do it. It gives the answer in this. And what is this? v0x, because it does not change. Horizontal component of velocity does not change because ax is 0. What about vy?
v0y minus gt.
Minus gt. So what about this v? What does he say?
Under
What does he say?
minus
He asks us to find, yes, tan theta. What is tan theta?
is vy by vx.
This v component by this component by this component. That is vy by vx. Theta is equal to tan inverse vy by vx. It is tan inverse. What is vy? That is v0 y minus gt divided by v0x, because vx is same as v0x. Okay, then he says, what is the initial angle of projectile motion in terms of h max? He calls this hm. We just write it h, but in the question he says hm means maximum height. And the answer he writes says theta 0 initial angle with which it is launched is tan inverse 4hm by r. This is his answer. We have to find this theta 0 in terms of hm, that is maximum height, and range. Okay, try to copy this. Try to copy this. I will find it. I will find the lost answer also. Okay. Okay, now please थोड़ा सा ध्यान दीजिए. देखा जाए तो आपने पहले ये किया है. चलो ठीक है, मैं उसी चीज से करूंगा जो आपने पहले किया है, मैंने दिखाया हुआ है. You know, h is equal to r by 4 tan theta. Do you know that?
Yes, sir.
कल किया था कि नहीं? But this theta is the angle with which it is launched. So tan theta is equal to what? 4h by r. No?
Yes, sir.
ये यहाँ जाएगा और ये नीचे आएगा. So theta is equal to tan inverse 4h by
r.
That is the answer. But he writes h as hm. So it is his terminology. Why you bother? If you tell me to do it again, I will do it again for you. Chalo, theek hai. There may be some students who may be interested. We know h is equal to, hm is equal to v0 square sine square theta by 2g. And r is equal to v0 square sine 2 theta by g. Let me divide them. hm by r is equal to v0 square cancels, 2 cancels, g cancels. It is sine square theta there, divided by 2 into this 2 into sine 2 theta. There's twice sine theta cos theta. One sine theta goes, it is hm by r, that is equal to sine theta by 4 cos theta. It is tan theta by 4. Now what is tan theta equal to? 4 will go here. So tan theta is equal to 4hm by r. So theta is equal to, tan will shift over here, tan inverse 4hm by r. That is your answer. Okay?
Yes.
This is the end of what you call as NCRT problems pertaining to projectile motion. Tomorrow I will go for AC Verma, right? So AC Verma I will solve tomorrow, and day after tomorrow I will solve resonance literature, and that will be end up. Then I will give you the assignments. Those who will report the assignments will be given further lectures. Those who will not solve assignments and report them to me, they will be denied these lectures. Okay? So I will call off the meeting now. Any question you want to ask?
No, sir.
Shazib, you have any question?
Sir, आज तो है नहीं.
Okay, if it is not there, okay, I am happy. If you have question,
मैंने आपको वो क्वेश्चन बोला था दिखाने को, वो ना वो
कौन सा वाला?
सर वो ना वो पैरेलल प्लेट कैपेसिटर्स के बीच में डाइलेक्ट्रिक वो डायगोनली डाला था उसमें वो K1 K2
दिखाएं, इसी वक्त दिखाएं.
जैसा आप मुनासिब समझे.
ठीक है, अगर आपको तो मैं दिखाता हूँ. चलो, let me call off the meeting right now and I will show that to you separately.
Okay.
Okay.